be conducted in the following order. At the beginning, I will introduce mechanical engineering very briefly, and we will see some interesting robots. Then, Yonsei University's unique course, Creative Design, will be introduced. Lastly, there will be a Q&A session. Chapter 1, about mechanical engineering. When you hear the word mechanical engineering, what image comes to you?
Iron Man. Wow.
Maybe Iron Man? I think he is the most famous mechanical engineer in the world, though he is not a real man. In mechanical engineering, these areas are involved. We will not deal with these things in detail. What I want to say is there are a lot of areas in mechanical engineering. In fact, when making a device, mechanical engineering is needed always. So, what is mechanical engineering? It is one of the major divisions within the professions, and its principles are involved in the design, development, and construction of nearly all the physical devices and systems which technology has produced. In short, mechanical engineering is about motion and energy. In mechanical engineering, there are four major dynamic fields. First, dynamics. Dynamic is a branch of physics concerned with the study of forces and torques and their effect on motion, as opposed to kinematics, which studies the motion of objects without reference to its causes. Isaac Newton defined the fundamental physical laws which governs dynamics in physics, especially his second law of motion. Second, solid mechanics. Solid mechanics is the branch of continuum mechanics that studies the behavior of solid materials, especially their motion and deformation under the action of forces, temperature change, phase change, and other external or internal agents. Third, thermodynamics. Thermodynamics is a branch of physics concerned with heat and temperature and their relation to energy and work. Last, fluid mechanics. Fluid mechanics is a branch of physics that studies fluids such as liquids, gases, and plasmas, and the forces on them. 여기까지는 좀 재미없는 내용인데요. Finally, boring section is ended. Now we'll talk about some awesome, interesting robots.
Wow.
First, we'll see the speech by Dennis Hong at TED. Dennis Hong is the most popular Korean robot engineer. He is a UCLA professor, and he is the founder and director of Robotics and Mechanics Laboratory. Let's see the video.
So the first robot to talk about is called Strider. It stands for Self-Excited Tripedal Dynamic Experimental Robot. It's a robot that has 3 legs. So this is an actual dynamic simulation animation. I was going to show you how the robot works. It flips its body 180 degrees. It swings its leg between 2 legs and catches the ball. So that's how it walks. But when you look at us human beings, bipedal walking, what you're doing is you're not really using your muscle to lift your leg and and walk like a robot, right? What you're doing is you really swing your leg and catch the ball. Stand up again, swing your leg and catch the ball. You're using your built-in dynamics, the physics of your body, just like a pendulum. We call that the concept of passive dynamic locomotion. What you're doing is when you stand up, potential energy to kinetic energy, potential energy to kinetic energy. It's a constantly falling process. So even though there's nothing in nature that looks like this, really we're inspired by biology and applying the principles of walking to this robot. Thus it's a biologically inspired robot. What you see over here, this is what we want to do next. We want to fold up the legs and shoot it up for long range motion. And it deploys legs, and it looks almost like Star Wars. When it lands, it absorbs the shock and starts walking. What you see over here, this yellow thing, this is not a death ray. This is just to show you that if you have cameras or different type of sensors, because it is tall, it's 1.8 meters tall, you can see over obstacles and bushes and those kind of things. This robot is a very recent project. It's called Raphael, robotic air-powered hand with elastic ligaments. There are a lot of really neat, very good robotic hands out there in the market. The problem is they're just too expensive, tens of thousands of dollars. So for prosthesis applications, it's probably not too practical because it's not affordable. We want to go tackle this problem in a very different direction. Instead of using electrical motors, electromechanical actuators, we're using compressed air. We developed these novel actuators for joints. So it's compliant, so you can actually change the force, simply just changing the air pressure, and you can actually crush an empty soda can. You can pick up very delicate objects like a raw egg, or in this case, a light bulb. The best part, it took only $200 to make the first prototype. This robot is actually a family of snake robots that we call Hydras. Hyper degrees of freedom, robotic articulated serpentine. This is a robot that can climb structures. This is a Hydra's arm. It's a 12 degrees of freedom robotic arm. But the cool part is the user interface. The cable over there, that's an optical fiber. And this student probably the first time using it, but she can articulate in many different ways. So for example, in Iraq, the war zone, there's the roadside bombs. Currently send this remotely controlled vehicles with an arm. It takes really a lot of time and expensive to train the operator operate this complex arm. In this case, it's very intuitive. This student probably first time using it, doing very complex manipulation tasks, picking up objects and doing manipulation, just like that. Very intuitive.
Isn't it amazing? Wow. Original video is 16 minutes long, so I edited the video. At the end of the video, he mentioned how they could be so creative. So if you want to see the original video, search Tennis Home at TED homepage. Second video is about Raptor robot. It is the fastest robot in the world that is made by MSC lab in KAIST. KAIST is short for Korean Advanced Institute of Science and Technology. Let's see the video.
팔인 듯이 사람.
넘어지네.
와, 중심차가 잘 오네, 역시.
기계하려면 훨씬 나네.
We saw some amazing robots. To make these amazing robots, creativity is the most important ability. In our Yonsei Mechanical Engineering department, we take classes named Creative Design to become creative engineer. I will introduce two projects that were performed in creative design class. First one is what I performed last year. It was for understanding energy transfer and maximizing of efficiency. The goal was to move ping pong ball when given only one motor and two 12 volts batteries. Constraint condition was that ping pong ball cannot be placed over 10 centimeters. Project outline is this. Before making the device, we designed first, and then through trial and errors, we chose best blade type. This is what we made. When the first blade is turned on, the wind generated by first blade makes the second blade rotate. Let's see how it works. The ping pong ball is moved up. It seems very easy, but it takes very long time to make these things. Second creative design class project is graduation project. Every student majoring mechanical engineering in Yonsei University should do this graduation project. The goal of this project is to make a device that could issue a patent. This is one of the project results this year. It won the prize at the competition. Device name is anti-crash over here. This device operates to stop the door when a person is behind the door. There is a sensor, an LED lamp, and an on-off switch. When this device senses that someone is behind the door, it stops to move the door. Let's see how it works. When there is a man behind the opening door, the sensor notices and makes anti-crash operate. Did you see? There are many interesting projects in creative design class as well as these two projects. This project helps students not only to develop creativity but also to understand subjects they learn. These are reference lists. If you want to know more about Dennis Hong or Letter Roba, go internet and search them.